What's up, you guys? In the last video, when talking about vectors, I used a specific way of printing out my vector. And that for loop was a little bit different than what you have traditionally seen with manipulating arrays. So why don't we take a look at a snippet of that previous program. So because I'm using vectors, I include the vector library, and then here we get to line 5. It's the same first vector that we created from our previous program, but now the area of interest will be in this line. And I mean, the introduction of this keyword is quite small, but it's very powerful and can make your life very easy. So here, by using the auto keyword, what I'm doing is that I'm essentially telling my compiler, figure it out. Figure out the data type that the variable is going to be. And that's something that's quite unheard of, especially coming from C, because you have to define your data type. Your data type needs to be known at compile time. So having the auto keyword making things a little bit more generic is a little bit unheard of, but well, because auto forces your compiler to figure out the data type at compile time, it's not such a big deal. So what are the benefits of using auto? The benefits of using auto include having a generic variable, and the strength of having a generic variable is especially important when it comes to loops. As you see here in this for loop, I have auto j equals v begin. And what is v begin? Without auto, the way of initializing this for loop, of creating the 3 statements of this for loop, if I didn't have the availability of the auto keyword. This is what that for loop would look like without the auto keyword. We have this strange esoteric data type called the std vector of integers, and it's an iterator. So it's an iterator that pertains to a vector of integers. And this is something that, well, you have to go and look up what vbegin does, what data type it is, and what it returns. And you have to do a little bit more research into what's going on. What does, std vector iterator do? You have to look at more details on that variable. And not only do you need to keep track of whether or not you need to use a std vector iterator, but here we have the int data type. If I were to do the same thing with floats, I need to change this with floats. So I need to keep track of a few things. I need to make sure that I'm using the std vector iterator. And I need to make sure that whatever vector that I'm trying to iterate through, I need to remember that data type. In this case, it's an int. It already sounds complicated, and we're only dealing with one vector. Imagine if you had to deal with 10 vectors. Some of them have primitive data types like integer or float, but maybe you have a vector of a user-defined data type, and that's where things can get very, very complicated. And that's where the strength of auto comes in, because instead of having to remember, std vector int iterator, I can just say auto j, and the compiler will be able to figure out that, hey, vbegin returns a std vector iterator, so we're gonna make j that data type. And instead of having to write this ugly mess, I don't even want to count how many characters is that. I can just write 4. So with the power and utility of having auto and having auto figure out the name of your variables, why don't I use it much more often? Well, one of the benefits is that it introduces more generic stuff. Like, you don't really have to worry. With the introduction of auto, you can make your variables more generic, in the sense that, well, it kind of doesn't really matter to specify the data type of the variable, kind of like how Python works, how you create your variable and you give it a value. But there comes a problem with that, because when you have some variables and you need to know how to use them, if it's auto, you're not going to know what that data type is. If I have something like this, let's say, for example, if I have something like this, I have no clue what this could even pertain to if I saw it for the first time in my life. It seems that this could be a structure that takes an integer, a string, a float, or a double, and a vector of integers. But at the same time, this can also be a class. And maybe I have various classes that have this way of initializing them. So if I have two classes that take inputs this way, which class is it going to be? Well, if I'm getting confused about it, what if the compiler does as well? Right, so as there are benefits to using auto and making your variables become more generic, there are downsides, namely the documentation of your variables. I mean, one of the best benefits of C++ is that all variables have a defined data type, and you can go find them, in the header files, or if they're part of, these standard libraries here, you can go look these up on the web. But that's if you know the data type. Here, with auto, I don't know. I simply don't know. And again, this is mostly with experience, but there are some cases where it benefits to not really know the data type of the variable, but in most cases, you should know the data type in the variable. So, with that being said, the use of auto seems really cool, but I'm already limiting the use of this. So what should I use auto for? The best recommendation that I can make for you is that you use auto for short-lived variables, namely loops, mostly for loops, because here, if we look at this line, J only exists in this for loop. It doesn't exist before it, and it definitely doesn't exist after. So, right, the lifetime of J, and it being a generic variable, which I don't know the data type of, is short-lived. So if it turns out that there's a problem with J, I know exactly where to look, because it has such a short lifespan that if there's a problem because I'm not using a variable correctly, well, here I have V, very unambiguously defined. The only ambiguously defined variable is J, and look, here's where it only exists. So when you find yourself in situations where you're going to have a short-lived variable, and it kind of doesn't matter exactly the data type of what it is, or if it's generic, using auto can be very beneficial. It's especially for limited scopes like loops and some functions and things like that really help. And with that, this paves the way for the next thing that I want to talk about, which is the ranged based for loop. So here, this for loop, I would argue that this is a ranged for loop because we're going the full range of our vector. And we can think of a vector as a container. Right, as you can think of arrays as containers, vectors are containers. They contain data inside of them. And they are also iterables because you can iterate through each element inside of the container. So a range-based for loop is when you go from the complete beginning of the container to the total end of the container, having your variable be equal to each of the elements at some point of the loop's lifetime, which we achieve here. But there's actually a simpler way to do this now that we've unlocked the auto keyword and that this is C++. And if I were to make a ranged-based for loop, this is what it would look like. And this is much simpler. So how can we go about looking at this? So with this range-based for loop, this essentially does exactly what is highlighted here. We go from the beginning and to the end of an iterable. However, the twist is here, we have essentially two categories of variables that are separated by this colon. To the right is going to be the container, meaning a vector or an array, something that actually has a begin and end like it does here. This is a container that we're going to iterate through. And what's to the left here? Well, here is going to be the name of the variable that's going to become our iterator. And what's really nice here, and well, I'm introducing something new, which will be figured out in the next video, is that I am using auto, just like I did with J, but I'm taking the address of X, and that's a little bit interesting. So doing this is a special kind of variable called a reference, and in a nutshell, a reference is like taking a copy of a already dereferenced pointer. So because I'm dealing with pointers and I don't want to edit this, I'm going to have a const here. So a const, whatever reference to one of the particular elements inside of V. So X becomes my iterable. When it iterates, it takes a reference to the beginning, and I do whatever I want with it. So here I'm just printing it, and because I'm not editing the value of X, I put the const here. Let's say, for example, I wanted to multiply each of the numbers by 2. If I wanted to do that with a range-based for loop, here's how I would go about doing it. I would simply get rid of the const, and now we can have something like this, where we're going to iterate from the beginning and end of V and x is going to be that iterator, and we're going to be adding 3 to every single element of the vector. And because it's a reference, the iterator is a reference, however I modify x, I'm actually going to modify the contents of v. Because here, I mean, again, in a nutshell, reference is like taking a copy of a dereference pointer. So if I edit x, whatever x is iterating through, I'm going to edit as well in here. And again, I put the auto keyword because I don't want to worry about the data type here. And this is safe, I mean, well, relatively safe, because the lifespan of x is only in this for loop. And the same thing for this x here. The total lifespan of the variable is just contained in that for loop. So it's short-lived. So if there is a problem with this variable and with how I'm using it, because it's part of a for loop and it's such in a constrained area, it'll be easier for me to diagnose problems here. But that about wraps it up for auto. It's a very powerful keyword. And while you could run the risk of making your program a little bit too generic and therefore a little bit more harder to understand, it can take some of the really annoying aspects of having your data types needing to be specified. It kind of lessens the pain of dealing with that, because you don't need to go and memorize like vector iterators or like other data type iterators and have to keep track of all that. You can just use auto to iterate through them. Anyways, that about does it for this video. With the next one, we'll be taking a look at references in more detail. Thank you.